Hey, what's up, everybody? College Board just dropped their free response questions for this year's at-home AP Calculus BC exam. I wanted to walk you through these questions and help you answer them so you can do your best on test day. So if you're ready, let's go. So in this question, we're given a continuous function that's defined on the interval -6 to 5, and it says the figure above shows a portion of the graph that consists of two line segments and a quarter circle centered at the point 5, 3. And they give us this other point on the graph. And then we're told that if the area from -6 to 5 of f of x dx is equal to 7, find the area from -6 to -2 of the graph and to show the work that leads to your answer. Notice that they only give us the graph from -2 to 5, and they want us to find the area of the piece off the graph. So what we're going to do first is we're going to calculate this area by splitting it up into little shapes. So this little triangle right here, right, it has a base of 1 and a height of 1, so that's an area of 1/2. From here to here, we have a triangle that's underneath the x-axis, and it has a base of 1.5 and a height of 1, so that's going to be -3/4. Okay, 1.5 times 1 is 3/2, divided by 2 is 3/4. We have this triangle over here that has a base of 1.5 and a height of 3. So that area is going to be positive 9/4. Okay, so that's 1.5 times 3, which is 9/2, divided by 2 is 9/4. And then this area right here, this area is actually the hardest part to calculate. So what we have here is we have a square, right? This square has dimensions 3 by 3, and then we want to minus out this quarter circle. So the area of that shaded region is going to be 9 for the square minus 9 pi, which would be the area of the whole circle, right? Pi r squared, right? These are my radii, 3 and 3. But then we divide it by 4 for the quarter circle. So if we add up all these things, we can write that the integral from -2 to 5 of f of x dx is just equal to all of these things added up. Well, a half minus 3/4 is a -1/4. -1/4 plus 9/4 is actually equal to 2. 2 plus 9 minus 9 pi over 4, the whole thing should add up to an area of 11 minus 9 pi over 4. Okay, so that's the first step in the equation. The next part is we need to use some integral rules. When we have the integral from -6 to 5 of f of x dx, we can split it up into two separate integrals, right? We can call it the area from -6 to -2, and then we can also add the area from -2 to 5. Right? It's as if we just split up our area in two bounds, and as long as these numbers match, you can split up any integral that way. Okay, so we can do some substitution then, right? We know that the left-hand side should equal 7 because that's what the question gives us. We're looking for this part, so we can just rewrite that. And then from earlier, we know that the integral from -2 to 5 is 11 minus 9 pi over 4. And then when you rewrite the equation, you should get that the whole area is equal to -4 plus 9 pi over 4. And that's your answer for part A. Now, if I were to reward points for this question, I think I'd probably give a point for you being able to calculate the area under the curve, this 9 minus 9 pi over 4. I think I'd also give a point for you knowing that the area can be written as the sum of two subintervals, so I'd probably give a point for that. And then for the third and final point, I'd give a point for the correct answer here. Alrighty, in part B, we're asked to evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. So let's see what we can do with this. Well, one of the properties of integrals is when you have a sum of integrals, you can split it up. When you have a sum inside your integral, excuse me, you can split it up, right? So it's 2f prime of x dx plus the integral from 3 to 5 of 4 dx. So that'd probably be my first step. Whenever you have a constant, you can also pull out a constant in front of your integrand. So we want to evaluate the integral from f prime of x dx. Well, what's the integral of f prime of x dx? The integral of f prime of x is just f of x, right? So it's 2. And then we're going to evaluate f of x from the lower bound of 3 to the upper bound of 5. And for this one, I'll just repeat this over here just to make sure I'm consistent with my work. The integral of 4, though, is just 4x, right? So then we just need to evaluate 4x for the lower bound of 3 and the upper bound of 5. And then we can just go ahead and do some plugging in, right? So we just need to evaluate what f of 5 is, and then we need to minus what f of 3 is. And then for the second half, we just need to do 5 minus 3. Luckily, we have the graph of f here, right? So f of 5, well, that's just 0, right? And then f of 3 is right here, but they give it to us in the question, right? They tell us that the point is 3 minus rad 5. And so you can just write out 2, parentheses 0, minus, make sure you put this quantity in parentheses, otherwise you might forget to distribute that negative. And then 4 times 5 minus 3 is just 8. And if you don't want to simplify anymore, you can just leave it like this. Otherwise, I can let you go ahead and simplify. But remember, as long as your number is numerically equivalent, it doesn't matter what numbers you use. So you do not need a perfectly simple answer. Now, if I were to reward points for this question, I'd probably give this question 2 points. I think I'd give 1 question for taking the proper antiderivative, getting this f of x and getting this 4x, and then I'd probably award another point for the correct numerical answer. So here we have part C. It says the function g is given by g of x is equal to the integral from negative 2 to x of f of t dt. Find the absolute maximum value of g on the interval negative 2 to 5 and to justify your answer. So whenever I see something like this, I think of the fundamental theorem of calculus part 2. Part 2, for those of you who don't speak French. If g of x is equal to the integral, then we can just write out that g prime of x is equal to f of x. Okay. I normally do this because I've seen on scoring guidelines that they'll just give you a point for writing that out if you recognize the fundamental theorem of calculus. So then what do we do? If we're trying to find the absolute maximum, we need to consider our critical values. Critical values are when g prime of x is either equal to 0 or undefined. Well, g prime of x is just our f of x, right? And this is our graph over here. Where is our graph equal to 0? Our graph is equal to 0 at negative 1. This is positive 1/2. And then we have 5, right? So we can list out our critical values as x is equal to negative 1, positive 1/2, and positive 5. So they'd probably give you another point there for looking at the critical values. And now, when you're looking for the absolute maximum, I think the easiest way to do absolute maximum is to do a t-chart. So one of the ways that AP Calculus has said that they can award you points is by you plugging in the critical values as well as your endpoints into the function to assess which values are either the greatest or the smallest depending on what you're trying to find. So we need to plug in negative 2, we need to plug in negative 1, we need to plug in 1/2, and then we need to plug in the number 5. Well, when we plug in the number 2 into g of x, we're just evaluating the area from negative 2 to negative 2, right? So that area is just 0. Now what's going to happen? If we're going to evaluate g of negative 1, that's saying we want to find the area from negative 2 to 1. We've done that over here, right? We did that for part A. So this answer is just 0.5. And now we need to do the total accumulated area from negative 2 to 1/2. So that's positive 0.5. This is a negative 0.75. So we have a net negative. And then we have g of 5. I think we did g of 5 in part A, right? So if we add everything up, we should get your final answer is 11 minus 9 pi over 4. And you can use your calculator to verify, but out of these 4 values, the maximum value is this one down here. So then how would you answer this? You should say something along the lines of g of x reaches a max value of 11 minus 9 pi over 4 when x is equal to 5. So now where would they give you the points? I think they might give you a point over here for doing the fundamental theorem of calculus. I think they'd give you a point for getting your critical values. And then I think they'd give you a point for somehow justifying that this is true, right? So in this case, the t-chart and this sentence is an appropriate amount of justification for this type of question. So that's 3 points. 1, 2, and then here's your third point. Part D is a limit question, and it wants us to find the limit of 10 to the x minus 3f prime of x over blah, 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 blah. So many symbols, right? So whenever I do a limit question, I always start out by rewriting the limit notation. They want to make sure that students are very specific with limit notation because the limit doesn't necessarily equal the value of the function. So I'm going to rewrite the question here. Now, after I rewrite the question, then I could go ahead and do a direct substitution to see what I get. 10 to the first minus 3 f prime of 1 all over f of 1 minus arctan of 1. So what is f prime of 1? Well, f prime of 1 is the slope of the graph at 1. Well, the slope of the graph, if I just go here and just do some counting, I get up 2 over 1, right? So then I can do this equal sign. As long as this equal sign lines up with the one above, then I don't have to rewrite that whole thing. Wouldn't that be awful if you had to rewrite it every single time? So then I can substitute 2 in for f prime of 1. And then what is f of 1? The value at 1 is just 1. And then hopefully you remember that arctan of 1 is pi over 4, not 45 degrees. Remember that all your trig functions should be answered in radians. But of course, since they're not grading you on the numerical value or your ability to do inverse trig, you could leave it as arctan of 1, honestly. And then at that point, you don't need to simplify any further. But just in case there are those of you who are sticklers for the simplest function possible, we can say that's 4 on top, right? And on the bottom, if we do a common denominator, it's 4 minus pi over 4. And then finally, we can multiply by the reciprocal, so we get 16 over 4 minus pi. We didn't have to do L'Hopital's rule on this one. Now, how would I award points for this question? I'd probably award a point here for getting that the slope of the function is equal to 2. And then I'd probably give a point for the final answer, making sure it's the exact numerical answer. And then I probably would make it a max value of 1 if you didn't repeat this limit notation and if you just started plugging things in. I think AP Calculus can be that nitpicky sometimes. Now we're given a new function. It says function f has derivatives of all orders for all real numbers x, and a portion of the graph is shown above with the line tangent to the graph at x is equal to 0. And selected derivatives are given in the table. It was above, but I moved it down to the side. And then we're asked to write the third degree Taylor polynomial for f about x is equal to 0. This is also known as the Maclaurin polynomial. So then if we want to do the third degree, we're going to need to write out 4 terms, remember that, because the first term is the 0th degree term. So that's f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared, and then f triple prime over 3 factorial times x cubed. Right, and some people are wondering, well, where are the other factorials, right? Remember that 0 factorial is just equal to 1, so I don't need to write that one over again. And 1 factorial is also equal to 1. So then where are we going to get the values from? So first off, f of 0 is just the spot on the graph, right? So f of 0 is just 3. F prime of 0, that's the slope of the tangent line. So we just do some counting, right? We go down 2 over 1. So f prime of 0 is negative 2. X. F double prime of 0. F double prime of 0, we're just going to pick from this table over here, right? This is just a fancy notation saying the nth derivative, so second derivative, third derivative, fourth derivative, etc. So then we can write that as 3 over 2 factorial is just 2 x squared, and then f triple prime of 0 is negative 23 over 2. And then 3 factorial is just 6. You don't have to simplify if you don't want to, but let me go ahead and simplify this a little bit more because I don't like this plus minus thing there. So it's 3 minus 2x plus 3 halves x squared. And then if we simplify that fraction, it's minus 23 over 12 x cubed. And that's your answer for part E. Now, how would I award points? I'd probably award 2 points for this whole thing, and it'd just be some combination of making sure that you have this whole notation right. What do people mostly forget? They tend to forget these things. And then I'd probably award a point for the final correct answer. So 1 point for the process maybe, and 1 point for the final correct answer. So in part F, we're given another function h, and it says it's defined by the integral from 0 to x of f of t. And then use the Taylor polynomial found in part E to find an approximation for h of 1. Well, I copied the answer that I got from the earlier part. And so this is one of those questions where it doesn't matter what you get for part E. If you got it wrong, as long as you do the work right, you can still get credit for part F. So let's go ahead and take the integral of f, since that's what is equal to h. So then we can say that h of x is equal to 3x minus the integral of 2x squared is x squared. The integral of 2x is x squared. If we take the integral there, it becomes 1/2 x cubed. And then we take the integral there, so we add 1 to the power. And then we divide by 4, so it's 23 over 48 x to the 4th. And then all we need to do is evaluate from our bounds. If we're plugging in 1 here, that means we're going to make that our upper bound. So let's write that just to keep things consistent. So then we can say, instead of this x, right, I'm going to replace this with the 1, and then I'll put this 1 over here. And now everything's consistent. So now we can say h of 1 is equal to 3 minus 1 plus 1/2 minus 23 over 48. And then the lovely thing about having the bottom bound of 0 is you're just going to minus 0 when you do the fundamental theorem of calculus, right? So that's just your answer for part F. So how would I award points here? I think the first thing I would do is give you a point for taking the integral of whatever your Taylor polynomial was and doing it properly. And then another point for getting the right answer. So this would be a 2-point question, I think. So we have part G, which is asking us to do an improper integral here. Even though it's attached with this graph in the table, it actually has nothing to do with it. So make sure you pay attention to what I'm doing when I evaluate this improper integral. So you're actually not supposed to have that bound up there, right? So when you're doing an improper integral, you start by saying, let's take the limit as b. They like to use the letter b in calculus. You can use whatever letter as long as it's not x, or p, I guess, in this case. And then we're going to write the integrand, and here we're going to do 1 to b. So the limit as b approaches infinity from 1 to b of 1 over x to the p plus 1 dx. So we know that p is a positive number. That means the exponent on the bottom is going to be a positive number. So then we can say that this is equal to the limit as b approaches infinity from 1 to b of x to the negative p minus 1, right? When we have a positive integral in your denominator, a positive exponent in your denominator, you can move it up to the numerator and make the whole number negative, right? But make sure we make both of them negative. And I'm being extra cautious to rewrite the limit notation. And now we can go ahead and apply the power rule. I'm still going to rewrite the limit here, though. Okay, the limit as b approaches infinity. And then the power rule states that when we take the integral, or take the antiderivative, we add 1 to the power, right? So negative p minus 1 plus 1 is x to the minus p. And then we divide by that exponent value. and then we're going to evaluate the bounds from b on top and not 0, 1 on bottom. Right, and now we can apply the fundamental theorem of calculus. I'm still going to rewrite this limit function here because we still haven't evaluated anything yet. So the limit as b approaches infinity of negative 1 over p to the b to the p power. Okay, so I'm plugging in b into my x value, right? And then since it's a negative exponent on top, I can reevaluate it by putting it on the bottom. And then I'm going to minus, and then it's minus a negative 1 to the negative p over p. Right? I do not need to write the limit for the second half of the evaluation just because that's a constant there, right? This is the only one that's improper. So let's think about what's going on right now. When we have an exponent in the denominator and we're raising the exponent to a really, really large value, that means the overall value of this limit is going to approach 0. So finally I can stop writing the limit notation and replace it with 0. And then over here I have 1 to the negative p. Well, 1 to the anything is just 1, right? So I just have plus 1 over p. So my answer is 1 over p. You're actually not going to get a numeric value here. It's going to be in terms of p. Now, where would I award points here? Number 1, I'd probably award points for doing this limit notation. Number 2, I'd probably award points for being able to calculate the antiderivative here. And then number 3, I'd probably award points for the correct answer. I think I would make sure that the student could not get full credit if they did not use the proper limit notation. I've seen on scoring guidelines before that even though questions out of 3 points, the max points possible would be like 1 if you didn't do the limit notation. So I would consider this a 3-point question. Alright, that's it for this video. If you have any questions about any of the problems, feel free to leave a comment below. Otherwise, if you found this video helpful, like this video or subscribe to our channel.